So this presentation is called Design to Production, or taking code from design and reusing it or trying to utilize it in production testing, uh, ultimately maximizing code reuse. I am watching the chat, so feel free to put any questions you have on there, and let's get going. So our giants are female. Look how he spelled female. Oops. All right. Mrs. Wu, who I'm not even going to try and pronounce her first names because I will botch it. She was a leading pioneer in physics. She was the first woman faculty member at Princeton, and she performed what is called the Wu experiments, where she learned that identical particles do not always behave in the same manner. So she's one of the first ones to discover that, and she won the Wolf Prizes, which is a big physics prize, in 1978. So, yeah. All right. So the agenda is we're going to look at the product life cycle, and then we're going to look at the problem. We're going to look at an overview of our framework, and we're going to talk about the design phase and then the production phase. So again, if you have any questions, put them in the chat. I have a monitor up here on my wall that I'll look up at. So a little bit about Tesseract. We have about 30 engineers, just over 30 engineers. We have a ton of expertise. We have a lot of expertise in web dev, backend stuff, because a lot of our customers are doing a lot of stuff with their data. So we have a lot of engineers with that expertise as well. So let's dive right into it. Product design lifecycle looks something like this. You have a concept. You start prototyping that. You go into what's called the design phase. This is where you're actually characterizing, building prototypes, collecting data. I put data collection on most of these. And then environmental. Sometimes this is part of the design phase where you're doing like thermal, Halt-Haas, vibration, a lot of those specialty, testing. And then you go into low rate production. Low rate production is where you're doing like the first articles, a lot of debug, a lot of semi-automated stuff. It's not all the kinks are worked out, so it's not quite something that you can hand off to a full-on operator or ship out to a contract manufacturer yet, because the product's not quite there yet. After you get through that, then you go into full production where you've worked out all the kinks, you're in full automation, very operator driven, very, push a button, walk away, come back, get your results, push the results into a database, whatever. And so this is kind of looking at the design lifecycle, but from a test perspective. And so if you look at where we insert ourselves into test along the way, it's generally at the design phase, we're very manual, hands-on, a lot of tweaking, a lot of changing things, a lot of rerunning over and over, cycling on the same test over and over to characterize it. Whereas in production, you're complete opposite. You're like, you want to put it out there, you want to push a button, you want to walk away. It's very operator driven, low skill set to run it. They come back, there's a green light, red light, basically did it pass or fail, and they move it on to the next phase based on that, right? So unfortunately, what usually happens is during this design phase, they develop their own code to do a lot of the design verification. And then they throw the UUT over this wall. And then on the production side, the test engineers over there will have to rebuild their own set of tests using their own tools. And a lot of times these tools are completely different tools, right? You might have LabVIEW over here, you might have Python over here, or vice versa. And so it's kind of this wall where you're getting a lot of duplicative efforts or reinventing the wheel on both sides of that wall. And so our goal is to really break down that wall, tear down that wall, develop code over here, and push it over to production and reuse as much as we can. And so that's kind of what we're going to explore during this presentation today. Are there any questions before I move on? Nothing. All right. Hopefully people are still awake. So in order to understand how we do that, or the way that we've solved this problem, is we need to look at our framework and understand our framework a little bit more in detail. And so the first thing we always start with is the hardware. You guys are familiar with the hardware. I don't need to go too much into this. Point is, you have a bunch of hardware out there performing some tests. The first thing, though, that we do is when we walk up to a bench or a project or whatever, we look at that hardware and we say, okay, what are the buses? What are the protocols? What are the instruments? What are the things that I need to talk to external to this computer? And that's where this HAL comes into play. Now, our HAL is very common in that we use object-oriented inheritance. We have this device type class layer where we have APIs that you can call from your code to talk to the hardware abstraction layer. We have a configuration file, kind of like they call it a factory pattern, I think, that kind of feeds into this. And during runtime, it decides which child class or model class, we call it, to use during execution time. And so simply by flipping a switch inside of this config file, you can be simulating 1 minute, flip a switch in your config file, and talking to an actual piece of hardware the next minute. Couple of unique things that we do with our HAL that I don't see in the industry very often is we treat the unit under test as a HAL item as well. It's just a bunch of buses or a single bus with a bunch of protocols that we need to talk to it. So it's just a peripheral connected to our PC essentially. And so we treat it just like we do any other instruments that's connected to our computer. The other thing that we do is we simulate all of our instruments and the UUT. And that simulation is done just through another model class. Again, just flipping a switch in this config file to switch over to that. The advantage of the simulation is that we can get to a 90% solution without a single piece of hardware on our stations. And so we can go into the actual piece of hardware with a very high level of confidence that the majority of our code's going to work. And then at that point, we're just integrating these hardware, these model class layers. The rest of our business, in our logic and all of that works just fine. Another unique thing about our hardware abstraction layer is we have this thing called a device manager. It manages all of the objects in memory. And this API knows how to pull those objects out of the device manager, go make the call, and put them back into the device manager. A lot of people will look at that and say, well, that's going to be really, really slow. It's actually really fast the way that it works. We haven't had any issues with speed with our HAL yet. I'm not saying that we might not run into that eventually, but we haven't yet. Another advantage of using this HAL, and why we put the UUT in the HAL as well, is you get automatic logging of all of your calls into this API, which we'll see in a minute, as well as we do shared connections underneath the hood. So for example, the 6700, if you're familiar with that, actually is 4 power supplies in one, but you're sharing the same VISA bus for those devices. And so what we do is you can have 4 instances of that power supply in your code, and those connections are shared with each other so that you're talking to the same VISA connection underneath the hood, but you're sharing that across the multiple objects. So really powerful. That's kind of an overview of our HAL. Now, one unique thing that we do, and the reason that these are boxes like this, is that we package everything up independently into their own PPLs. So we can add to our HAL dynamically, essentially, so that when we deploy, and we'll talk more about this in a minute, we're just grabbing a bunch of packages, the packages that we need. Our ultimate goal is to walk up to a test station, run a wizard, pull down a whole bunch of packages, and have a 60 to 70 to 80% solution, depending on how common the hardware on that bench is. And so that's why we package it up that way. Any questions? Does the shared connections use resource locking or some force?
Yes, it does.
Yes, it does. Let's just leave it at that. PPLs, yeah. I don't know if that's a good ad or a bad ad.
Is he asking? Pack project libraries.
Oh,
LVLIBPs.
so what are they? Pack project libraries. So LVLIBPs. Yeah. Yes. They're basically the equivalent of an assembly or a DLL in another language, where everything is in its own namespace. Yeah. So, for example, we have this device, device configuration editor that I can pop open. And so this is how you would configure the HAL.
So says your photo.
What's that?
So says the photo.
So says the photo, yeah. So if I wanted to add a new instrument to my computer, I come in here, I could choose. You can see I have a bunch of different devices. I don't have all of the devices from our library on here, but if I wanted to add a new power supply, I could, and then I could choose what kind of power supply I want to talk to. For this demo, I'm going to actually do just a simulation one, and we'll call this, I don't know, just call it GLA demo, power supply. We'll create that. And so what that does is later, I'll call that from our code, but you'll see that that name is that configuration. So if I wanted to change that to a different, a different power supply, I could come in here, switch it over, hit OK, and all of a sudden I'm talking to that power supply. So I'm going to change it back to a simulation though. Okay. Oh, thanks, Q. Equals hair loss. Peter guy's a funny guy. All right, so the next phase, once we have that HAL done, we can talk to all the hardware perfectly, of course. Then we move to the again, the design side where they're doing a lot of manual stuff. So you can create manual GUIs, and you can do one-to-one for the HAL. So this is a simple power supply GUI. This is what it would look like. You choose your power supply, you can set your volts, all that stuff. You can create whatever kind of manual GUI you want on top of that HAL for whatever debugging purposes you want. And you can, and it doesn't have to be a one-to-one thing. You could have a manual GUI that runs a spurious emissions test or a current draw test or a whatever kind of test. And so you can talk to your unit under test, your power supply, your power meter, your spectrum analyzer, and those can all be, you know, underneath a single GUI, or you can have different GUIs for each. The point is these GUIs are something that designers would use, or more low-level technicians would use to debug, to characterize, to play around with, get more intimate with the hardware than you would in an automated environment. Once those manual GUIs are created, this is where it kind of stops with the design side because they've got what they need. But then when it gets thrown over the wall, and we'll look at another slide here in a minute that kind of demonstrates this better, is we go into this full automation kind of side where we want to reuse or maximize reuse with that hardware abstraction layer. And so we don't have to reinvent or recreate that HAL when we go into automation. We just reuse it there. So I can go into depth if you're not familiar with test stand. Basically, test stand is this engine with user interfaces, user management, report plugins. I have many presentations out there about test stand. I do a lot with test stand. We architect test stand a little differently than most people. We have different layers of sequence files in our test stand applications. We have the client file, which main purpose is to get information about the DUT, as well as decide which we call these test abstraction layers to call. These test abstraction layers have very specific requirements to that execution. For example, if you're doing an ATP, it might be a simpler execution than you would for a dry run or an environmental stress screen or a whatever else. And you can create these test abstraction layers really quickly and really easily. But then we have these test modules, which we'll create one of those in a little bit here, that are kind of equivalent to like a test case, if you will, where the test case is a simple measurement or a simple algorithm that goes and performs some kind of test and returns some values back to this TAL to evaluate. The test modules are also, all of these are packaged independently as well, so that you can add to your test station really simply. An example is we were testing ultrasound probes for one of our customers. The test modules were pretty well defined and in place. Everything else was well defined and in place. All we had to do to add a new ultrasound probe to the test station was create new test abstraction layers. And because they were all packaged independently, the FDA, who signs off on the tests for these things, only had to qualify that one TAL instead of the entire system. And it went from a 2-month process down to like a 1 to 2 day process because of that. They had up to 100 probes or 75 probes or something like that with different test abstraction layers on that machine. And so that's the advantage of this architecture, is it really plays well to high mix, low volume, or even high mix, high volume for that matter, environments. So any questions on that? Unrelated to hair loss. With test stand, you get out of the box storage. You guys are familiar with a lot of the out of the box stuff with test stand. You got any kind of format you want. We can write our own plugins if we wanted to. Very cool stuff. This is why we use test stand, because it is a framework. And the different architectures you use in test stand, you have something which can. Okay, yes. So your question is, can we run in parallel? Yes, you can do parallelism in test stand. So inside of your test abstraction layer, let's say that you wanted to kick off something that was monitoring. So you had like a test module that was monitoring, I don't know, some DAC channel, right? And you wanted to collect all of that and put it in your report. But then inside of this TAL, you also wanted to kick off other tests as that DAC channel was monitoring. You could easily do that inside of here via the sequence calls with their ability to perform multi-threading or multi-execution. There's huge differences between both of them. Now, if you're doing like a batch test, you want to use the right process model for that. And that will give you multi-threading, right? Where you can test, I don't know, up to thousands of parts at a time. I've never seen it do 1,000, but maybe you're doing a single ATP test on like a functional test, and then you want to go over to a ESS type thing, and you want to put 5 of them in the chamber. You would just switch out this client file for one that's attached to a batch process model, and then it would go kick off all of these TALs for each of the part numbers, and they would call these test modules. So I don't know, there's several ways to answer that question, but absolutely you could do parallelism. I would say LabVIEW is much better at parallelism than any language out there. I mean, that's what it was designed to do, right? But TestN gives you a lot of that functionality if you want it. So then, of course, you have your automated test GUI. This is just a simple test stand UI that I believe Slade created. And it's, just running your test stand scripts. So one thing that we do is we have this tool called Task, which I'll open in a minute here. Task is a UI that kind of houses all of this. And so we can have these manual GUIs plug into Task. We can have these automated GUIs plug into Task. Task looks something like this. It's your standard, kind of LabVIEW UI with this panel in here that displays the different modes. A mode is a GUI. Think of a mode as one of these automated or manual GUIs. And so you can load those into here dynamically. You can load them on the fly. You can preload them, pre-configure them. You can configure tasks to load different ones for different products. And so these modes, you can reuse these modes, I guess is what I'm getting at, across benches, simply because the modes are packaged independently as well. We have different panes that you can do different things with. Let's say you want to constantly monitor. In one example, we were testing X-ray tubes and we wanted to monitor a the door to the lead-lined room, so that if anybody opened the door, we would shut the entire system down. And so we would have an LED here that was green, and when anyone opened that door, there were some other triggers that caused it to go red or yellow. It would shut everything down and turn the entire system off. You have a status pane, you have active status, you can put stuff into here. You can change the logo to be whatever you want. And so Task is this kind of GUI that puts everything in the same application space, if you will, right? So let me pop that open so we can look at it. Here's what it looks like. Oh man, blurry logo. All right, so here's your modes. Here's what it looks like. Here's your test stand login. That's your test stand UI. I can come in here. Here's a manual GUI for a power supply. I can choose that GLA demo power supply that we added to our config earlier in the demo. I can set the voltage. I can set the current limit. I can turn the output state to on. I can do a refresh to grab all the values off of there. And you can see, it's doing its stuff. Now, the cool thing about Task is you can click on any one of these other GUIs. We have this one called the How Debug. This thing's pretty powerful in that you can choose any of the instruments that you have set up in your config file. Here's that GLA demo one. And I can actually click, again, all of this is in LabVIEW runtime. I can click on any of these API calls, and I can run them independently if I want to. So for example, if I wanted to go get the output state, it's coming back as on, right? Because over here, I turned it on. Now, if I come back over here and turn it off, I may have to refresh. No, that's good. And then I can come back over here, run that again. You'll see that it's off. That means that how that device manager can share those between different themes, between different UIs, right? And so eventually we're going to have the ability to come and right click here and add these dynamically. So you could be paused in test stand. And that's another powerful thing is with test stand, we can run it. We'll just run this one. I can do like a dry run test. I can break. Oops, and we caught it right before it turned off that power supply. So this turned on the power supply right here during this test. This is one of those test modules. Then it turned the RF on our DUT, and then it got the current, and then it turned it off. So I can actually pause test stand, and this is really advantageous in like space applications. We do a lot of space testing because when anything breaks you're testing something that's going into space, anything pauses or breaks inside of test stand, you have to call about 50 doctors and scientists into there to look at it. And it's very painful, and you have to kill test stand usually, and that kills all of your, all of your handles, everything, and you can't then debug properly. It's just harder to debug. And so with this, the way that we've designed this HAL is you can pop over to here and you can grab that. I'm using the DC power supply in this scenario, and I can get the output state, and you can see that it's on. And so in test stand, if I step over, this one turns that off. And so I can jump back down there and I can choose that, and I can get that state, and you can see that it's off. This gives me the ability to share those connections between test stand and LabVIEW, which is a huge bonus for a lot of people, because historically it's really hard to debug in both, especially like if something goes awry in test stand. It's just you have to kill test stand, you kill all your sessions. Now I'm gonna just resume so it finishes this out. We failed. Ooh, stop it. There's our report. All the while, we've been logging everything that's been happening underneath the hood. And this is one of the powerful parts of our hardware abstraction layer is you can log to any console, you can log to a database. You can attach as many loggers as you want. You can attach loggers to only certain instruments or just to your unit under test if you wanted to. You can see here's my TXCCA, that's my unit under test calls. If I only wanted to see that device, I could attach just to that device, and I would only show that. And so I could come in and I can filter based on the log level, the device class, the device name, right? So if I only wanted to see my spectrum analyzer calls, I could apply that and it would show me all the spectrum analyzer stuff, the timestamps. It would show me the values that were going in and out of those calls. And anything in our house just automatically gets this logging capability with it, right? So and here's kind of a text output if you want to look at that. But here's I like this table one better. It's easier to visualize what's happening. So so that's pretty powerful, right? So imagine you're a designer, you're over there on the design side, you have all these GUIs, you're playing around, you're getting your design just right, but you're like, hey, I really want to capture what I'm doing so that I can just play it back, right? And so, but before I jump into that, I wanted to show you this slide. So ultimately, what we're trying to do is we're trying to capture what these design verification guys are doing, and we're trying to take those over and turn them into test scripts in TestAnd that we can then run in a production type environment, right? And so this is kind of like a Venn diagram, as Gary called it. So on the production side, you have the automation, the heavy automation. You have that hardware abstraction layer. On the design side, you have the same how. But what is really hard is to capture that manual GUI stuff and then move it over into a more automated environment, right? And so if I hop back over to task, we have this thing called the record and playback GUI that I have to give credit to my team for doing. Kevin Shirey was a big part of that. Q, who was on the call, was a big part of that. And as well as Tom Cantner and Jacob Burnham. A lot of guys put a lot of blood, sweat, and tears, slave into this in the last couple weeks to get it ready. So what you can do is you can create a new session. You can click on this record, kind of like a macro in Excel. And so let's say that we want to create a current draw test, okay? And so we're going to set the voltage, we're going to set the current, we're going to turn on the power, we're going to wait for the UUT to boot, we're going to get the current, we're going to set the UUT state to on, then we're going to get the current again. So we're going to get the current twice, once before we turn the full TX CCA on, and then once after, and then we're going to turn the TX CCA back to off, and we're going to turn the power off. And so really, if you look at the pieces that we need a power supply HAL, a UUT HAL, and then we need the debug GUIs to do it as well. So coming back over to task, we have our record and playback UI. I can start this kind of like a macro recorder, right? And I'm going to go over to this DC power supply GUI. I'm going to choose the DC power supply, and I'm going to set the voltage to 5.5, and I'm going to run that. I'm going to set the current limit to 3.1. I'm going to run that, and I'm going to turn the output state to on. Okay, so now the next step is I want to go and turn my, actually I want to get the current limit because I want to see what the current draw was on my unit under test before I actually turn it on. And so I'm going to get that output state here, and then I'm going to come back and turn my RF on, and we'll put it at like 15.5 gig. And we'll run that VI, and then I'm going to come back over here and I'm going to grab that output state. Now, it might be better to do this in manual GUIs. I like using this HAL debug GUI. And I'm going to grab that current, and then I'm going to come back over to my transmitter, and I'm going to set that state to off, and then I'm going to go turn my power supply off. Now, all of that was being recorded into here. You can see all of those states, all of those calls into the HAL that I made. So we've captured all of that. You can see the order that it is. You can see these pre-waits. Maybe you're like, hey, I don't want to wait that much in between each one of these. So you can come to this editor, and you can like select all of these, and you can say, I want that pre-wait to be 0. And then you can accept that. You'll see it will set that pre-wait to 0, but maybe there's some steps that you do want some wait on. So let's say that we want to set the output state to, where is it? Right here. let's say that before we get that current, we want to wait for the duct to boot up, right? And so we might put a 2-second delay in there. And then we want to turn it on. And then before we get the current again, we want to put another 2-second wait in there. And so we've got these 2-second pre-waits, but the rest we don't care. We want it to just fly through that stuff, right? And so now that I've gotten, I can come in here and kind of edit some of these if I want. I can edit the values in here and save them if I want to change the value from 3.1 or whatever. And now I can save that. Oops, come here, mouse. I can save that out to a file. We'll just call it a current draw test. Again, put yourself in the shoes of a design engineer. You've gotten kind of your method down for doing this test. Now you want to just save that off, and every time you want to go run that again, you could come in here and just run it. So if I go over to this log console and I clear everything, I can come back to this recorder. I can start it. It'll run through everything. You see it's waiting for those 2-second delays, and then it's complete. And then I can see that it happened because everything is in my log, right? And I can run that as many times as I want. Now, the cool part is if I want to export this into test stand, right? Because now it's like, I've got this down. I feel really good about this, you know. I feel really good about this, this kind of test case or test module or whatever you want to call it. Now I want to save that out to test stand, and I want to make a sequence out of that, right? And so you click on this export button. You can actually export it as a CSV file as well, but I'm going to export it to test stand. We'll go put it in that same path. We'll call this current draw test. And you hit export. It's generating a sequence file for you, which will pop open here in a second. So I can go open that in test stand in the editor if I want to, or I can come back to here and I can open it up in this as well. And I could run it from here. So I could go execute that. Test your UTs. You're going to get your, it's got it loaded. Get your dialog. There's your weights. There's your steps. That's what we generated. It's setting all of those things through the instruments that you set them through. There's your report. Now the report's kind of cool, but we want to put limits on some of those current draw calls, right? And you can see that it happened if you come back over here to the log. You can clear that. So what I can do in test stand is now I can just massage it a little. Now put yourself in the put yourself in the shoes of a production guy who's sitting over there and he's like, okay, what does the design engineer want me to test, or how should this thing be tested? Then they just have to come in here and massage a couple of these things, right? And so where's the, I got the output state, not the current limit. I was supposed to get the current limit. That's okay. Well, I don't know why I did that. What's that? Yeah, you could come in here and make it a pass fail test if you wanted to. Got a little bit of my head ahead of myself there. But yeah, you could do that if you wanted to. It's going to be completely useless, but pass fail, right? And if it's on, then it passes, right? But what you would probably want to do is you would probably want to throw a current draw in there, or get the current, right? So you could actually edit it. Get current. Yeah, we'll just call it get current. Then you could go. Do I have that one? Yeah, get current. Boom. There we go. We'll throw this in. Dot. Oh, we gotta go change the step down. Okay. Change it to a numeric limit. Now we can do dot numeric. I'm going to set up your limits. Say we want it to be between 3 and 5. Those are pretty big limits. We'll throw that down. Change this to maybe only show a couple of decimal places. Is that right? F.2, right?
2.f.
Oh yeah, you don't want that. You're right, it is. It's 2.f? No,
Percent.
it's it's .2f, right? Yeah, there we go. Gotta remember my my string stuff. Okay, we don't need this step anymore, so we'll get it. Boom. We'll grab that one there, throw that down. Actually, on this initial current draw, we might want it much lower, right? We might want it, hey, we only want to be pulling, between 0 and 1 amp if the RF's not on this card, right? So we can save that, close it out, come over here, get updated. You come in here and run it. Yes, that did work, Dan. Thank you. Uh-oh, we failed. There you go. So it's pretty powerful. What you can do with this. The idea being that you could actually, if you're in design on the design side, just save these, open them, rerun them, export them to CSV or CVS, or even build into here a better report mechanism if you wanted to create an exporter. And I think that exporter you can override and or add to it pretty easily different ways to export the data from this as you execute it. So that's kind of how you would do it. So if we walk through our framework, kind of reiterating what we just saw there, what you would do is you have your dot, you have your instruments, you create your HAL layers, all of these HAL layers here. Then you would create, some debug GUIs, and this is kind of where design stops, right? And then taking that into production, you create your TALs, your test modules, your test and UI, your client file, and then you might also have packages for doing system link or PDF or XML or whatever you wanted to export your plugin or whatever plugins you needed on that test station. If you had custom plugins, they would be in here as well. So the point is, and I want to go actually back a couple slides to this slide, because this captures kind of how we deploy this system, right? Is you have all of these packages out there, some with test and files, some with pack project libraries, some with configuration files, some with other files. And the idea is that you would walk up to a test station and it would be kind of like a buffet, right? You would say, I need a little bit of these, I need these ones, I need those ones, I need this, I need this. And you would grab the packages that you would need, and you would put them into a feed or a solution, or if you're using System Link, you could put them on the server and push them down to the machines via System Link. And that's kind of how you build this. And so as you build up these HAL libraries for your company, the design side can grab them as you build up these task GUIs, these other tools. Anyone in the organization can just grab those and put them in their solution really easily. And that's kind of the idea behind this. So that being said, are there any questions, anything that you would like to see over here that I did not talk about or demo? Silence is golden. It's late at night. We all want to go home. Cool. Very well documented framework. It's powerful. We use it in many industries. It's great for high mix, low volume. How do you handle the logging when it goes to production in a regulated environment? How long do you keep logs? So it kind of depends on the customer and what they want. If you go back to this slide right here, in that low rate production, you want a lot of those logs more than when you're going into full production. And so those logs you can turn off via config files pretty easily. And so it just depends on the customer.
It's all plugins too, so you can custom.
Yeah, and it's all plugin based, so you can have as many logs or as little logs. And if you want to move that to push to a database when you're in production versus a flat file over here versus a flatter file over here, if that's even a thing, you can do it however you want. But the point is, this is probably one of the best places to have those logs. It's good here too, and it's good here, actually really good here. But this is where you see a lot of that need is in this low rate production type environment where they're kind of running it automated a little bit, but they're also doing a lot of debugging. They need that data. Usually once they go into full production, you don't see a huge need for that because everything is working pretty hunky-dory. The only time that you really need those logs is when you're doing heavy debug, because your production tests, if they're created properly, you're capturing all of the things that you need and putting them in your reports or your databases. And so it just depends. Again, I guess that's the answer I would give to your question, Peter. Sorry, there's not a better definitive. Customer A does it this way, customer B does it that way, but it's just all over the board. So, and that's the power of this, is the flexibility to use it how you want. So, any other questions for Tal? Early slide test script overview. Okay, so what you're asking about, Andrew, and correct me if I'm wrong here, is this, correct? This Tal thing? Yes, okay. So I guess the idea is that these are sequence files, and I guess I could probably, I have a Tal. Yeah, let me pop this open so you can see what that looks like. And actually, while I'm in there, let me open up TML here too. We'll do a current draw TML. So this Tal file is just a sequence that's a bunch of calls, sequence calls to those test modules. This is what a test module looks like. So this would be a current draw test module. It's kind of similar to what we created in our demo there, where it's just turning the unit under test on, getting the current draw, whatever. Here's another example, is the spurs one. So this is performing an RF spurious emissions test. My mouse is really jumpy, I apologize. It looks like I don't know how to use a mouse. But this is what the spurious emissions one would look like, where it's sweeping across and looking for spurs on a spectrum analyzer, right? And yeah, I'll get into that in a second. If I don't answer your question, then you can yell at me. So these test module libraries are really just functions that you would perform, and this Tal is calling them and doing the analysis for you. The reason that we needed abstraction and how we define abstraction is that anything that is specific to that unit under test, or that can be parameterized for that unit under test and maximize the reuse of this test module, is what gets pushed one way or the other. And so if it's like, oh, I can parameterize that frequency, or I can parameterize the weight before this or that, or what I'm collecting, you want to parameterize as much as makes sense, but you don't want to go overboard, of course. And so there's really kind of an art to that of where you say, okay, this test module, and the Tal all starts with the test module. This test module is a piece of code that can perform X, Y, and Z with this dot, right? And so then you can call that from your Tal, and that gives you that ability to reuse that. And so you can see I'm calling that spurs test 3 times here. Now, if I open up another Tal for dry run, you can see that it's using that spurs test, but it's only doing one of them. And so I can really quickly throw these Tals together. In some cases, less than 5 minutes, throw one of these together and call it from my code, from my client file, as long as I make it dynamically, able to call these Tal files. And so that's kind of how that works. And I think I answered your question. If I didn't, maybe I need some more clarification from you. So, do you have any input on that, Gary?
I think you covered it unless there's more specific questions.
Yeah. Okay. We've just seen a lot of power with this architecture.
Maximizing reuse is really the thing that we go for.
Yep. Maximize and reuse only for the purpose of stability, because these are all tested and they're proven commodities. And you don't have to go regress test them every time you add a new test to your test station. And then the other value that you get out of it is the reuse. So you're developing a lot faster because you're just grabbing pre-made pieces and throwing them together. Any plans for supporting NI semiconductor test systems? We've done a little bit with the STS, but you could apply this architecture to that pretty easily. We don't have any plans in our roadmap right now, but if you're interested, reach out, PM me or DM me or look me up on LinkedIn and let's talk. We could probably pretty easily, apply this to that industry. We deal a lot in aerospace and defense. We deal a lot in medical, and we deal a lot in automotive with this framework. We do a little bit of semiconductor, but usually we're using the out-of-the-box NISTS stuff for that. So, any other questions? Anything you want to see in here? Nope. Cool. Yeah. If you do have any questions, feel free to reach out. Let's talk. Yeah, thanks for, we're going to be done early here. Well, I guess technically we only go 45 minutes, right? Is that what they said? Yeah, feel free to reach out. Do you have a good way to create the customer's pretty PDF reports? You want to answer that one, Gary?
Go for it.
I guess I'm not sure what you mean by pretty, but I'm assuming you mean the non-crappy out-of-the-box NI one.
For the XML. But they have a PDF version now, but you still have to flatten it. So
yeah.
The style sheet.
In a former life, we created a thing that did that, but we don't have that code here. So, yeah. If you want something like that, Peter, we can do it. We have done that before. We don't have something in our current library that does that.
But yeah, you can make a plugin that does that.
So, yeah, just create a custom plugin.
Yep.
So, yeah, we've done a lot of plugins. Done a lot of presentations on plugins too. So. Yeah, maybe we'll get with you if we have a need for that. So, Slade's point is testing in 2020 out of the box are prettier. Yeah, well, they've had PDF since 2017, 2018.
Yeah,
it's just not. It hasn't been as good. So, thank you, Jose. All right. Thanks for coming, everyone, and enjoy the rest of your time.